Okay, I think we can start. So, well, welcome to this class. This has a long name, Robotics of Control of. I can't even remember the name. Control of robotic legs and arms, something like that. But really, what it is really 3D robotics, and the systems we'll consider in this course are manipulators, so arms, and systems on legs, quadrupeds specifically, and that's why I gave that long title. But it's essentially 3D robotics. So that's how it will differ from an earlier course I've taught, 410, which is essentially 2D um, kinematics, dynamics, control, and so on. This is going to be 3D robotics. This is what you probably need if you want to, let's say, simulate a robotic system. Um, More valid, more useful than the 2D course. Not that 2D is not good, but 3D is what the world lives in 3D, and that's what this course is going to be about. So there's only me in this course. There's no teaching assistant, so all questions should come to me. There's no textbook for the course. I have some reference books there in the syllabus. You can find the syllabus in the syllabus tab on Blackboard. I'll of course provide you with course notes and other Python code. So a lot of the material taken here is really taken from various books. Sometimes it's research papers, and really my experience working in robotics for the last 15 years. So it's really difficult for me to tell you a textbook for this course. We'll use Blackboard for everything: syllabus, announcements, notes, videos, so on. Really, this was a question I got from many people asking me, what do I need in order to succeed for this class? Well, really, I don't assume that you know anything about robotics. I'm assuming that you're seeing a first robotics course, and I'll keep it to that level. I do expect you to know linear algebra, AX equals B, matrices. How do you take a 3 by 3 matrix, multiply with another 3 x 1 matrix to get a vector? Differential equations. So how do you integrate equations of motion? So that will be doing numerically, but I think this is something which you'll probably know if and you don't really need to revise this. And basically calculus, derivatives, and so on. It's nice to have knowledge of Python, but I'm not assuming that you know Python. Okay, so you will hopefully by the end of this class, if you've not learned Python, you'll probably get better at it. I'm not saying you'll become an expert, but the hope is that you'll uh, know something about Python, which would help you to get your job. So maybe robotics is not for you. You don't want to get a job in robotics after you finish this course or finish your degree, but hopefully the knowledge in Python will help you in your career, because Python is embraced by most people in industry because it's free, right? It's open source free. We meet Monday, Wednesday, 9:30 to 10:45. This is the room, cell E3279. However, if you can't make it to class, that's absolutely fine. I'm actually streaming this on Zoom, so it's on Zoom, and I'll be doing this every single class. So you can use that shortened link. You can also see that on the syllabus. Sometimes it may ask you a passcode. It's 400 plus. Now it's not like if you can't make it for class in person or through Zoom, that's absolutely fine. I'll record this. I'll post it on Blackboard. I'll also post the Python code. I'll also post the notes. So you don't really have to attend if you cannot make it. It's really up to you. Whatever helps you to succeed in the course. Okay, so I will be recording it. I put it on YouTube because for whatever reasons I cannot just put a video on Blackboard because they have capped it to whatever limit. And if I load 3 videos on Blackboard, that'll take all the space I can use for the course. So I have to put it on some place, YouTube. And so please be mindful of that. So if you ask questions, it might actually be part of YouTube. And so if you I try to cut parts when people ask questions, but if sometimes I may not succeed. But chat is the best way if you don't want your voice to be heard on YouTube. It's very unlikely that it's very there's so many videos, so I don't think it really matters, but it might matter to you. Then just be mindful of that. The grading is 50% project, 50% homework. Somebody asked me what is the grade distribution for this class. I've never taught this class before, so I can't tell you that. I did teach 510, which is actually also robotics. It was a grad level class just like this one. I think 90% of the students got A grade in this class. It basically boils down to you just submitting the homeworks and doing the project reasonably. And it's not like if you don't do a good job, I will give you 0. It's not. It's like you get credit for doing attempting, right? And so the point is not to punish you, but to help you to learn robotics. So really, if you do the homework and project, you shouldn't get a less than A grade in this course. Uh, okay, so one thing I try to do in all my courses is keep everything as much free as possible. And I think for this one, everything is free. You don't have to buy anything. Python is free. I'm going to use Visual Studio Code, but some people use other ones like PyCharm or what else is there? PyCharm, Jupyter Notebook, so on. But I just want to stick to Visual Studio Code. MuJoCo is the software. It's basically a robotics simulator which we'll be using. It has a C version, which is how it is. C or C++. I think it's C version. But then there's a Python binding, so the Python bindings call the C files, and then that's how you can use it. We'll be using that, and then you can use generative AI tools absolutely fine. That would be ChatGPT, Gemini, and so on. In fact, I would highly recommend that you use them for this course in order to program in Python or even any help. That's fine, absolutely fine. And what I've done this time, which is different, is I sent all of you, whoever registered with this class, a link to join Slack. So we just have a Slack channel. I think that it will help you to code specifically, because this MuJoCo sometimes, it's good. There are not too many resources, and I think you'll be benefit best by posting there. You'll get much faster response than asking me via email, and that's because I think there are some people in this class who are taking this course from my lab who know MuJoCo. So it's not like not just me, but they also can help you. So I highly recommend that you try to join Slack. I've sent you the link. It's also on the syllabus. Okay, so what's about homework? What I try to do is I let you work in groups, but don't go more than 2. You can work in groups of 2. That's absolutely fine. What happens when you go groups of 3, 4, one person or 2 people slack off, and I don't want that to happen. We'll keep the homework due on Sunday, and I'm really flexible about it, as some of you might have noted. It's not like I'm going to punish you for submitting late. That's just let me know, and we'll work with that. The submissions are through Gradescope. So there are questions where I expect you to type or write, in which case they'll come through Gradescope. But then some things require you to code, which you can send it by email. And the homeworks will clearly indicate how I want you to submit what homework. Okay. The project is again 50% of your course of credit. Again, you can do it in groups of 2. My plan is, and I'll come to what is going to taught in this course, but approximately in week 9, so a semester is 15 weeks long. So approximately week 9, I'll assign the project, and it will be really you choosing something you want to create, not me assigning you a project. But essentially, you'll be taking some things from this course, creating a robotic system to do something, and you will decide what you're going to do. You'll decide which system you're going to work on, and then we'll be doing a presentation the last week of classes, and then I may ask you to send me files or presentation. We'll see. Okay, and you can do that in groups. Okay, now this is important. I know somebody who does not like generative AI and will not use it for their work. Okay, but some of you might want to use it, and you should totally use this for this class. Okay, please use this is the way I think it's going to be in academia. This is how it might be in industry. Sometimes industry is very sensitive to what things you put on these generative AI tools, because they can actually get the data. But for the most, I think it's a useful skill to be able to use generative AI for your own purposes. Okay. Anybody is a computer science student, computer engineering? Okay, only mechanical or non-computer science. Okay, so here's the thing. I think that because we are in mechanical or non-CS engineers, and we know programming and we can use these tools, we have a much better shot at jobs than computer science, because that's going to make them defog, right? So I think it's a software. ChatGPT, Gemini is a software which is made by software engineers to make their own jobs hard to come by, because you really don't need them, right? We'll see how that goes. Okay, so there are bonuses. Typically, course evaluation, I might give extra homework. So if you did not submit any homework, then you can obviously bump your grade. doing the bonuses. Office hours will be through Zoom. I'm thinking of Monday, Wednesday, 11 to 12:30. I might change that, but it's the same link. If you want to meet me in person, let me know, email, and we can set up a time to meet. My email is over there. It's also on the syllabus. Now, you can also use Slack, and I highly recommend using Slack. The thing about Slack is there is like a mobile version. I have Slack on my phone. There's also a program which you can load on your computer. So Slack on my computer. What happens is when I want to quickly send a message, I use my phone, like instant messaging through Slack. But then on the computer, I can actually send files through that. So I would highly recommend having it on both places, computer as well as your mobile phones. Okay, so what's going to be taught in this class? Really, if you look at the way you want to get a robot to move is basically you need to go through these 4 steps. One is you need to describe the movement of describe the positions of the robot. So if the robot is in a certain pose, given the angles, how do you describe its movement? Let's say if you want the hand to be at a specific location, you figure out the angles. So that's basically the kinematics. Then there's differential kinematics, that is the velocities. And there's another concept called Jacobian, which is useful for that. So that's the second part. The third part is you need to describe movement. In the world space, gravity is going to always conspire against you. So you need to be able to write equations. And that's actually another whole step. There's a lot of important things happening there because you need to make it fast enough that you can do these calculations on the fly. And once you have built all these 3 ingredients, then you go to control. You need to generate a trajectory and then you track it. So typically, if you want the arm to move from point A to point B, and there's a trajectory which you generate, and then you go to track it. And dynamics or gravity works against you. There's also forces which come because of the velocity. You need to take those into account, and that would be the tracking problem. And so then there's something called finite state machines, which we'll be talking about. These machines, there's basically a method to program logic. So that will go hand in hand with control. So my goal is to get through these 4 parts in the first 8 to 10 weeks. Okay, so a 15-week semester, 8 to 10 weeks, we finish this. And once we do this, you hopefully are ready to start with the project. The remaining 3 weeks or 4 weeks, we'll try to do more stuff. So for example, these are like, I just put some topics here. I may not do all of them, or I may do some of them. I might do some of the important ones, depending on what projects you choose. So here are some other things which we could do. The first one is basically a convention which is used in industry. Well, it's a very old convention. I think it's worthwhile to know it. Optimization is, if you want to do control in an optimal way, that minimize something, that would be numerical optimization. Linear control is very useful because what you do is you take equations, you make them linear. Once you have equations are linear, you can use many of the tools in control. State estimation is when you want to estimate the position velocities and there's noise. Motion planning is if you are in an environment like this with clutter, there's obstacles, how do you go along it? That would be motion planning. Computer vision it's obvious. You have a camera, how do you use the camera to make your useful of the information comes from there. And then machine learning, which I'm not sure if I'll get there, but that's another thing people use to program robots and do other things. Okay, that's machine learning is, by the way, is very, very broad. And my hope is that some of you will take all these things and then take one of these and then explore it in your project. Okay. Now, if you're in a lab where you're doing robotics work, it's absolutely fine to choose a project which is related to your thesis or your lab project. That's absolutely fine. In fact, I would suggest that you do that because it's more meaningful for you than trying to do some random project. Okay, so we'll be using MuJoCo. There'll be 2 systems we'll be extensively studying. So what we'll do is I've taken UR5. It's a very popular manipulator. It looks, let's see if we can load this. So that's what the UR5 looks like. You might have seen it. It's got a very distinct blue color. Many robotics labs have this. It's called UR5 because it can take 5 kg payload. There's a UR10, and then there's UR2 or something like that. Okay, so it's a 6 degree of freedom robot, which means there are 6 joints, and you need 6 joints because the end effector, that is the hand, can be described with 6 numbers, like 3 positions, 3 orientations. So you did minimum 6 degrees of freedom. So that's one. The other system we'll be looking is the quadruped. This is a robot made by Unitree. And then what you'll do is for your project, this is just a suggestion. MuJoCo has a model gallery. So the bipeds, humanoids, manipulators. This is the one I took. These two actually have the same, they look different, but they have the same. You can use the same controller for this. We've tried this and it works. Here are a series of quadrupeds, grippers, arms, lots of them, and then drones and okay. So hopefully for your project, what you'll do is you'll choose a system. So one thing you could do is you could take one of these systems and apply the tools you learn from this class. That's one option. The other thing you could do is you could take the existing system, which I'll be teaching in this class, which will be the essentially it will be the quadruped, and then the UR5, and make it do something which is more interesting, like use maybe numerical optimization or do motion planning on the quadruped. You could also do a combination, which is I think interesting. You could take this arm, one of these arms, maybe a simpler one. This is all 6 degrees of freedom. There are 3 degrees of freedom arms. I think this 6 degrees, 6 degrees. Okay, they're all 6 degrees. You could take one of these arms, you can simplify it, and then you could put it on top of this robot, which we'll be talking in this class, this robot, sorry. And then you could basically do a project based on that. This one already has an arm. You could take the Boston Dynamics spot, and then you could do something with the arm. So it will be both then. It's called loco manipulation. So there's locomotion, movement in the legs, and manipulation. So